Hi and welcome back for the third video in the Python core section. This video is about list comprehensions and other functional programming concepts. In this video we'll discuss the use of list comprehensions, we'll get back to generators with a few more details, and we'll conclude with an overview of the functions map, reduce, and filter. All these concepts are very useful because they let you write clean code that is going to be very efficient, especially when you deal with larger datasets. A comprehension is a construct that allows a sequence to be created from another sequence. Most commonly, we talk about list comprehensions. Let's say we have a list of numbers and we want to build a list of the respective square numbers. So we can start with an empty list, and while we iterate over the original list of numbers, we append the result of the operation x squared. The same operation can be performed with a list comprehension, and as you can see, the code is much more compact. The first part of the list comprehension is the output expression, x squared in this case. The second part of the comprehension is the iteration over the original sequence. You can also have optional predicates to filter the sequence, as we're going to see in a moment. Now let's consider a more complex example. Let's say we have a nested loop over two sequences and a conditional predicate to check before we append the item to the list. We can reach the same outcome with an equivalent list comprehension. Again, the first part is the output expression, the second part is the iteration over the input sequences, and finally we have the optional predicate. Some people also like to break down a complex list comprehension over multiple lines. Even though this is perfectly valid, sometimes it's less readable, so use your best judgment to assess readability. Next, let's look into dictionary comprehension. List comprehensions are more widely known, but we can use the notion of comprehension also to build a dictionary. Let's say that you have a list of words. We may want to build a dictionary where these words are the keys and the related values are the output of some function. In this example, we use the built-in len function to capture the word length. One option is to create an empty dictionary, iterate over the list of words, and assign keys to values within the for loop. Alternatively, we can use the dictionary comprehension syntax using curly brackets, which is much more compact. Similar to list comprehensions, we first have the output expression in terms of keys and values, followed by the iteration over the given sequence. The comprehension syntax can also be used for generators. As discussed in the previous video, generators are iterables that support lazy evaluation, so their values are not fully loaded in memory and only obtained on demand. The syntax for generators simply uses round brackets instead of square brackets, and it's otherwise identical to list comprehensions. The output is a lazy object, so if you want to access the values, you need to iterate over the object itself. Finally, let's introduce the functions map, reduce, and filter. If you come from a functional programming background, you might be already familiar with these concepts. Let's start with map. Let's say you have a function f, and you need to apply it to every item of a sequence of numbers. This is somehow similar to what we have done with list comprehensions. The map function takes the function to apply as first argument, and the sequence of inputs as second arguments. The output is a lazy object again, so this is similar to a generator comprehension. If you want to access the actual values, you need to loop over the object or cast it to a list. If your function takes multiple arguments, you can pass multiple sequences to the map function. In this example, the first item of the sequence A and the first item of the sequence B are passed to the addend function, and then the second items are passed, and so on. Next, the reduce function. The reduce function applies a function of two arguments to the items of a sequence in a cumulative way until the output is reduced to a single value. In this example, the function addThem is applied to 1 and 2 first, and the output is applied to the following item. The process continues until we end up with a single value, which is 10 in this case. Finally, the filter function. Given a function that returns true or false, the filter function returns a generator with all the elements for which the given function returns true. In this example, we filter the even numbers from a sequence of the first 10 integers. The filter function used here is essentially equivalent to a generator comprehension. To summarize, in this video we have discussed some functional programming concepts around the notion of list comprehension. We have seen the comprehension syntax applied to generators, and we have discussed the use of functions like map, reduce, and filter as a functional programming way to deal with sequences. The next video is about dates and times.